Sometimes we're asked to solve a triangle that is not a right triangle, but we're also not given an angle side pair. So in a situation like that, we would use something called the law of cosines. So again, the law of cosines is used to solve oblique triangles in these two given scenarios, where we're given two sides and the included angle, so the two sides and the angle in between them, which would be classified as a side angle side triangle, right? Because it's side angle side, two sides and the included angle. Or if we're given all three sides, if we're given a side 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 triangle. So side angle side and side 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 triangles, we use law of cosines, whereas a side side angle, angle angle side, or angle side angle triangle, we would use the law of sines. So let's take a look at what the law of cosines says. So if we're given triangle ABC, the law of cosines says to find the side, to find one side, basically what we're going to do, let's say we're given a side angle side triangle. So we're given this side here, we're given this side here, so we're given sides C and B, and we're given the angle measure A. So if I want to find my third side, it would be, we isolate that side, so A squared equals the sum of our two sides squared, so B squared plus C squared. So it kind of looks like the Pythagorean theorem, minus 2 times B times C times the cosine of our given angle. So that's the law of cosines. So it's A squared equals B squared plus C squared minus 2 times B times C times the cosine of our given angle. And that would be the law of cosines. So let's take a look at using the law of cosines to solve some triangles. So we want to take a look at this first example, and we want to solve this triangle. So we're given side A and side C and angle measure B. So we need to find side B first. So we need to find side B first. So B squared, so the side we're looking for, is equal to the two sides squared and their sum, so 2 squared plus 4 squared, minus twice their product, 2 times 4 times 2, times the cosine of our given angle, the cosine of 45 degrees. So simplify this, so 2 squared, that's 4, 4 squared is 16, 2 times 4 times 2, that's 8 times 2 is 16, so minus 16. The cosine of 45 we know is the square root of 2 over 2. Use order of operations, so we can take this sum here, 4 times 16, that's 20. 16 times the square root of 2 over 2, that's going to be, if we plug that into our calculator, it's going to be something like 11.3137 something, right? Our calculator is going to continue going on. We don't want to quite round yet because we're going to have to take the square root of these, and we want our answer to be as accurate as possible. So when we take this difference and take its square root, so this is what B squared is equal to, we're going to take the square root of all of this, right? Take the square root of all of this, and we're going to get that B is equal to 2.95 approximately. So this is about 2.95 units. So that was how we use law of cosine, to find this measure, and this is a side angle side triangle. Now, to solve the rest of this triangle, you can continue to use law of cosines, or you could use the law of sines. Now, if you're going to use law of sines, you're going to want to try and solve for the smallest angle remaining. And the reason why is because if you use law of sines and try and find the larger angle, if this angle is obtuse, when you take the inverse, it's not going to give you the obtuse measure. It's going to give you the acute measure, which would be its supplement, and we might not recognize that. So if you try and find the smaller angle first, that means that we can then just use the sum of these subtracted from 180 to find our larger angle. So let's find the measure of angle A. So using the law of sines, it says the sine of A divided by 2 equals the sine of 45 divided by 2.95. Multiply both sides by 2, we get that the sine of A is equal to 2 times the sine of 45 degrees, all divided by 2.95. And take the inverse of this to get the measure of angle A. So A is the inverse sine of all of this stuff. So plug this into your calculator, and you'll get that the measure of angle A is about 28.6 degrees. So this is about 28.6 degrees. And to find the measure of angle C, so angle C is just 180 degrees minus the sum of these two measures, 45 degrees plus 28.6 degrees. And that gives us that the measure of angle C is 106.4 degrees. So 106.4 degrees. And there we've solved our triangle using the law of cosines.